All right, so we are going to be working through problem number 36. How much heat in kilojoules is needed to convert 35.0 grams of ice at negative 16 degrees to liquid water at 36 degrees? So we notice, forgot a question mark. So we noticed that we are starting at ice at 16 degrees. Okay, so I drew my heat curve here. So here's where my solid is. Okay, we know for H2O our solid is 0 and below. So here's where I'm starting with negative 16 degrees Celsius. All right, and then we are ending at liquid water at 36 degrees. So if we're ending at liquid water at 36 degrees, that means here on my map, or my graph, all right, this is where water, H2O, is liquid, okay, from 0 degrees to 100 degrees Celsius. And so I just drew a mark in the middle somewhere to represent our 36. All right, we know that when we have a temperature change, we're going to use the formula Q equals mc delta T. C is our specific heat, Q is heat, m is mass, delta T is our change in temperature. All right, if we have a phase change, we're going to have delta H, our enthalpy, which is heat. So Q and H, they are both heat. They are the same exact thing. M is your mass. So, hey, we're going to use the same mass for each problem. And then heat of fusion or heat of vaporization. Well, heat of fusion is used when you are going from a solid to a liquid or a liquid to a solid. Heat of vaporization is liquid to a gas or gas to a liquid. So, looking on our graph, all right, we see that we are starting here. We need to stop at every corner and start a new problem. So if I am starting, so problem number 1, I am currently ice and I'm starting at negative 16 degrees Celsius and I am going to, well, let's look at our graph here. We're going to keep going, stop. We hit our first corner right here. Okay, and that is at 0 degrees Celsius. So as ice, I have to stop at 0 degrees Celsius. So this problem, I have a temperature change because the temperature is changing from negative 16 degrees Celsius to 0 degrees Celsius. All right, second problem. Now, at 0 degrees Celsius, this flat line is showing me that I am staying at 0 degrees Celsius, but in this problem, since my temperature is not changing, my phase is changing. You can only have one or the other happen. You can't have both a temperature and a phase change happen. So here, I am at 0 degrees Celsius, and I'm going from ice or solid to water, which is my liquid. Okay, so that means I have my phase change. So that's going from here to this corner. So at this corner now, I no longer am a solid, but now I am 100% a liquid. So then if we're following, so there's 1. Here's my number 2. So I'll put a 1 right there. I'll put a 2 right there. All right, so now that I've hit this corner, now that all of it is the phase change is done, now I'm going to go to the end of my problem. I'm now starting at 0 degrees Celsius as liquid water at this point, and I'm going all the way up here to my ending point of 36 degrees Celsius. So that means I have a third problem. So that means I am water or my liquid. All right, I am starting at 0 degrees Celsius and I am going to 36 degrees Celsius. All right, so that is how it is broken down, where I'm starting at ice at negative 16 degrees Celsius and then ending at liquid water at 36 degrees Celsius. All right, so now that we know that, we are now going to put our knowledge of temperature change, phase change, and our temperature change into our two problems, our Q equals mc delta T or our delta H equals mass times heat of fusion, since it's heat of fusion because it is a solid to a liquid or liquid to a solid. So ice. So we have Q, which is what we're trying to find. Mass, which we saw in our problem, is the 35 grams. So I'm just going to put the 35 grams right here. 35.0 grams. All right, specific heat. Specific heat for solid, a liquid, and a gas are completely different. The specific heat for solid H2O, which you found in your notes, and I put on Schoology a heat curve of H2O note page that has all of the formulas and all of the specific heats for H2O, is 2.06 joules over grams degrees Celsius. All right, then delta T. Delta T is change in temperature. So that means that it's temperature final minus temperature initial. That is what delta T is. So for this problem, my final temperature for just ice, because this is a separate problem than the whole thing combined, is 0 degrees Celsius. So I'm going to write 0 degrees Celsius minus, because it's final, minus initial. My initial was negative 16. So now I'm going to put that in, negative 16 degrees Celsius. So you're minusing a negative, which becomes a positive. So my delta T in this problem equals 16 degrees Celsius. And then we'll solve. We'll solve that after. I'll write everything out, and then we'll solve it together. All right, number 2. Since I have a phase change, not a temperature change, I have to use delta H, my enthalpy, equals mass times heat of fusion, since heat of fusion is the one used for solids to liquids and liquids to solids. So, again, heat of fusion is in your notes in the heat curve of H2O note page. All right, so my mass, it's the same, 35.0 grams. All right, and then the heat of fusion for H2O, and I want the one that has grams, not moles, because you can also do moles times heat of fusion, is 334 joules per gram. All right, and then that's it for that problem. Okay. All right, last problem. So now our whole phase change is done. We are now 100% liquid. We are at 0 degrees, starting at 0 degrees, and we are ending at 36. So this means we have a temperature change, which means we're going to use Q equals MC delta T. So M, 35.0 grams. Specific heat of H2O, liquid H2O, in the notes is 4.18 or 4.184, either one. If you do 4.184, you'll just get just a slightly different decimal or a slightly different answer, and it's not too much, and that's totally fine as long as you show your work. All right, so final temperature in this problem for the water is 36 degrees Celsius. So I'm starting there. So 36 degrees Celsius minus my initial for my liquid water is 0. So I'm going to put that back. So 36 degrees Celsius minus 0 degrees Celsius, and my delta T equals 36 degrees Celsius. All right, so I now have all 3 problems complete. Now we just need to solve. Since this is where we're starting, and this is where we're ending, once we have found all 3 answers, 1, 2, and 3, I then can add them all together to get my final answer. All right, so let's get a calculator, and let's go. All right, so number 1. All right, so 35.0 times 2.06 times 16, and that's my mass, my specific heat, and then my delta T of my ice. I get 1,153.6 joules. And I got joules because if I look here at my specific heat, I have joules per grams degrees Celsius. Well, if I multiply them by grams and the unit in my specific heat, the grams in the bottom, it's canceling out. Same thing for my temperature. If I'm multiplying by degrees Celsius and I have a degree Celsius on the denominator of my unit, then I get to cancel those out, leaving me with joules. So I get 1,153.6 joules. All right, so let's do our phase change. So now it's 35.0 times 334. All right, and I get 1,000 or 11,000, 690. Same thing. If I look here, I have my grams here, and then I have my joules over grams. That means I can cancel my grams out, leaving me with joules. If you did it in moles, the unit for heat of fusion is kilojoules per moles. You'd have to convert this 35 grams of H2O to however many moles of H2O by using the molar mass. All right, last problem. I have 35.0 times 4.18 times 36. All right, and I get 5,266.8 joules. All right, so I have all three of these. I now have to add them all together because all three problems are added to show our start of our problem to our end of our problem. As we see here, our start of our problem going to our end of our problem. So each one is a piece. All right, so 1,153.6 joules plus 11,690 joules plus 5,266.8 joules, and that will equal ta-da-da, 18,110.4 joules. So we're almost done. All right, our final answer or question, had asked us to put it in kilojoules. Well, we know through dimensional analysis and through the metric system that we have 1,000 joules for every 1 kilojoule. So I technically just need to move my decimal 1, 2, 3, and my final answer should be 18.1104 kilojoules. If you can look at your significant figures in your problem, you can either do 2 or 3. I can't remember which one that I put, but you can overall say your 18, I'll just say 18.1 kilojoules, and that is your final answer.